So I spent like weeks building this ridiculously complex custom board game curriculum for my younger sibling, making these increasingly difficult scenarios so they could learn the ropes.
All right. Let me guess. It completely backfired.
Yeah, totally. I realized way too late that I had accidentally just trained them to defeat me forever. I mean, they are unbeatable now. But it's actually the perfect setup for today's deep dive because you shared these fascinating notes with us on Meta AI's new Autodata framework.
Yeah, and it turns out AI is doing exactly that. I mean, it is this massive, incredibly optimistic leap forward in how we think about machine learning. We are looking at an autonomous system that's literally learning to be a data scientist, purely to train itself.
Right, and our mission today is to figure out exactly how this AI automates its own education. Because right now, for you out there who follow this stuff, you know that to get smarter AI, we need massive amounts of data. But human-written training data is just, well, it's too slow.
Exactly, we are hitting a ceiling. Autodata solves this by basically acting as the data scientist. It creates, analyzes, and then iterates on its own training material. Like, you want to optimize a workflow, you look for the bottleneck, right?
Yeah, totally. And speaking of optimizing workflows, this is a great time to mention our sponsor, Embersilk. Just like Autodata optimizes AI learning, Embersilk automates human workflows.
Right, so if you need help with AI training, software development, or just uncovering where agents make the most impact for your business or personal life, you should definitely check out embersilk.com.
Absolutely. So bringing it back to Autodata, it essentially takes that kind of optimization and turns it inward. Okay, let's unpack this. It feels like a brilliant teacher who writes a test, sees the whole class ace it, and realizes, wait, this test is way too easy. I need to write a harder one to actually measure their intelligence.
That is a perfect analogy.
Yeah.
And the way it writes that harder test is through this really clever setup called agentic self-instruct. Instead of one model just, guessing at what makes a question hard, it sets up a full multi-agent dynamic.
Okay, so how does it actually know if a test question is good?
Well, it uses a challenger model to write questions based on actual computer science papers.
Hmm.
Then it tests those questions on two different solvers. There's a weak model, which is small, like 4 billion parameters, and then a strong model, which is massive.
Wait, massive meaning like hundreds of billions of parameters, right? Because that means the strong model can hold and process vastly more complex logic.
Precisely. So the challenger throws the question at both of them, and then a judge AI scores their answers. The ultimate goal for the challenger is to create a question that the strong solver completely aces, but the weak solver completely fails.
Oh, wow. That makes perfect sense. Because if both fail, the question is probably just gibberish, right?
Yeah, exactly. And if both pass, it's way too easy to be useful. So this dynamic forces the AI to find that exact sweet spot of difficulty.
And the results in the notes were striking. Like with standard methods, there was only a tiny 1.9% score gap between the weak and strong models. But Autodata widened that gap to a massive 34 points.
Yeah, it's huge. The strong model hit nearly 78%, while the weak model dropped down to around 43%. So the AI genuinely learned how to write a test that separates raw power from basic understanding.
That is wild. But what's fascinating here is that it goes a step further, right? Like if it can write a better test, it can learn to be a better teacher overall.
Right, through meta-optimization. Over hundreds of iterations, the AI actually analyzed its own failures and rewrote its harness.
Meaning like the core set of instructions and rules it uses to evaluate data.
Yes, exactly. But here is where it gets really interesting. During this meta-optimization, the AI eliminated negative grading rubrics entirely.
Wait, this is where I have to push back because that is totally counterintuitive. We have been taught our whole lives that deductions are how you grade tests. Why would penalizing errors make the AI worse at creating good data?
Well, it comes down to how the judge AI behaves. When you penalize an AI for small formatting errors or, minor missteps, the judge gets hyper-fixated on those tiny mistakes.
Oh, I see. So it causes the strong model to fail even when its underlying logic is actually genius. It misses the forest for the trees.
Exactly. So by eliminating negative penalties and instead capping the positive points a model could earn, it forced the AI to look for actual signs of brilliance. It stopped nitpicking formatting.
And that simple rule change caused its validation pass rates to jump from, about 13% to over 42%?
Yeah, over 233 iterations. It is just incredible.
It really is. And it brings us to the bigger picture here. The future isn't AI replacing us. It is co-improvement. Humans and AI acting as co-researchers to solve the universe's grandest problems. We guide the intuition, and it scales the learning.
I completely agree. It is an incredibly hopeful trajectory for human progress. We are literally building partners that can teach themselves how to help us better.
Which leaves you, the listener, with this to chew on. If an AI can now perfectly calibrate a curriculum to teach a lesser AI, imagine a future where a personalized AI perfectly calibrates its curriculum to your exact learning speed and style. What skill would you master first if failure was mathematically impossible?
I would love that thought.
Right. Well, if you enjoyed this positive journey into the wonders of learning on Intellectually Curious, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.